In this video, we're going to cover drawing chairs as well as the two important positions for the bonds that can exist on chair structures. So our first thing we're going to do is actually draw out the structure of a chair. We can see, and we kind of talked about in the last video, that we're kind of outlining the carbon-carbon bonds in this structure, looking at the chair on its side. And so how we typically would go about drawing the structure of the chair, there's a few different ways to draw it. I tend to put the two side bonds first, connect them with an upside down V in the front and a right side up V at the back. So this is how you can actually get the structure of the chair. It takes a little bit of practice to draw these types of structures. What we're going to talk about now that we've kind of got that chair structure, drawn out all the carbon-carbon bonds at least, we're going to talk about those axial positions. So these are the positions on the ring that are going to be going straight up and straight down. And these positions are very specific in terms of what carbon these bonds are on. So as we can see in this chair structure over here, we have a bond going straight up on the carbon at the rightmost back. So that's this carbon right here. That's the rightmost carbon on this particular model, as well as in our chair structure. So we're kind of looking at it on its side, but also on a little bit of an angle, because we see that this upside down V, the peak of it is a little bit to the left, like we drew in this chair, the little bit to the left of this carbon at the back, the kind of the dip in the actual V here. So we do have that offset a little bit. It's typically how we draw our chairs. For our axial bonds, we're going to have them only, so this position here can only have its axial position pointing straight up. And so let's draw in that bond here. We're just dealing with H's right now. So if we draw in that bond, it's going to be straight up to the H. Then the one in the front, so we're kind of moving around the ring in a clockwise direction. So we've gone from here to this one here. We see that this one is going down. So this axial position can only be going down. We can't draw the axial position on here going up because that's not how the chair structure is. That's not how we look at chairs. And so we do have to draw this one going down. So specifically, this axial bond's going to go down, and then basically we're going to see that they alternate. So we're going to go up and then down and then up and then down again. So let's fill in all of those. So we have the one up on the front, that's the only axial position there. We have the one straight down on the front left, straight up at the back right, and then straight down. And we're doing that little break in the bond again, just to show that that axial bond is actually behind the bond of the ring right here. So if we were to highlight what we have done, we'll use green because it seems to stick out the most on the actual model. So with this one, we drew this bond going straight up, then this one straight down, this one here straight up, then this one here straight down, up, and we made a break in this bond here behind the ring. Let's do that when we do this as well. So those are going to be our axial positions. What is important about these positions is that they actually are a little bit more crowded than some of those equatorial positions. So with these ones, we are going to have a little bit more crowding. So those are the ones that are straight up and straight down, a little bit more crowded in these ones, and it does matter on which carbons are you drawing the line straight up and which ones are you drawing them straight down. So we see that they alternate straight up only on that front carbon, the back left, and the back right one, and then they're only straight down on the front right, the front left, and the back one. So it is really important where we're drawing these straight up and straight down lines. That's how the axial positions are, and again, they are a little bit more crowded. Then what we're going to see next, we're going to take a look at those other positions that we hadn't drawn out. So these positions here that are kind of going along the equator, those are going to be our equatorial positions. So for these positions, we're going to do the same thing that we did for the other one, where we're going to draw out our chair structure. And it's going to hopefully help you practice a little bit to draw this again. We can draw our upside down V in the back, and then our V in the back, and then our upside down V in the front. Doesn't really matter how you connect them as long as, we're seeing this kind of offset between the front and the back one, just like we see here that they're a little bit offset. So now for the equatorial positions, now we're dealing with these ones that are kind of going on an angle. We can see that this one here, for example, will start at the same place. This one here is actually parallel to the line here. And so that's how we're going to replicate that when we draw out our H on here. We're going to try to make that line parallel with this one over here. So that line and this line are parallel. When we come to the next carbon, we're going to see that this line for this bond here that's going on an angle is actually parallel to this line over here. So when we draw it over here, we're going to actually make this line parallel with our line to our H. So let's go ahead and draw that in. So we made it parallel. And then we see that this one at the front is parallel to the sides of the ring, either one you can look at. This one maybe looks a little bit more parallel from this exact viewpoint, but we're going to try to make that parallel here. So we're going to draw our H out so that it's parallel to this line. We're going to do the same thing on this other side. So we have this H coming out on an angle. It's parallel to the one that's kind of one bond away from it. So it'll be this one here. So we're going to make the H come out on an angle so that it's parallel to that right front side of the ring here. The one at the back is a little bit harder to see on this exact model because it is at the back. But this one is parallel to this line here. So this line, we're going to draw parallel to that one. And then the very last one, we have that one as well parallel to the sides of the ring. So we're going to draw that one going out in that same direction we drew our sides of the ring. So really what's all parallel is the sides, the front and the back equatorial one. The ones that are kind of slanted in this direction are parallel to the H's on this, or the bonds on this carbon and this carbon. And then this one is parallel to this line, and this one. And so you're going to have 4 parallel lines in here. Let's highlight what we have drawn in. So for our first hydrogen, we were saying that's this line. Then we drew this one out for this line. Then we drew this one for this one. We drew this line for this one. Then we had this one at the back we can kind of see. And then we have the equatorial position there. So we see that these ones are not pointed straight up and down. They're actually kind of going out towards kind of the equator of the ring. So they're pointing out kind of in their own directions. And that actually is going to be good because it's less crowded than axial positions. So if we have groups attached at these positions, they tend to have more room and it tends to be a more stable position on the ring. And so that's what we're going to be looking for when we're working through our problems, and we're going to be asking about, what is the more stable chair conformation for these certain groups. And we're going to see that equatorial positions, if there's a chair that puts that group in the equatorial position, that's going to be a lot more favorable than one that puts it in the axial position. And the thing is that then the next video, we're going to talk about chairs flipping as well. So we're going to put a group on here and then we're going to do some chair flips. And that's basically like our rotations for our Newman projections, except these can't actually rotate because the ring is pretty rigid. So we can't actually do a full rotation around a single bond. And that's why we're going to be doing chair flips instead. So that's what the next video is going to talk about. We're going to be talking about equatorial and axial positions. So if you can practice drawing out your chairs and maybe rewatch this video if you need to, I would suggest doing that before going on because we're going to be just drawing out our chairs and drawing out these positions in the next video.